All right, guys, here we are. Um, Hopefully that test on Monday went okay. Um, if it didn't, well, we are finally through it. That was quadratics. That was for sure probably the hardest unit for most of you guys in this class. And it's a shame we had to do it remotely like this. But yeah, that's going to be it for quadratics. We're going to be starting a new unit today. So we're really in the home stretch now. Um, this is our last unit of the year. We are doing statistics, right? So for a warm-up, I just want you to pause the video for a second and ask yourself, what do you think statistics is? Just write down some words or ideas that come to mind. All right, so usually when I do this in class, for stats, people tell me to think of numbers, they think of data, of information. Someone might give me a sport like baseball. There's lots of stats in baseball, or the NBA, or any sport, right? Like in the NBA, you have stats like rebounds per game, or assists per game, or points per game, right? And then there's like advanced metrics or advanced statistics. So, and in baseball, that goes kind of crazy, right? But for this class, our definition of statistics is going to be as follows. So statistics, I can't even spell it. That's a shame. Statistics is the collection organization and presentation of data. So for us, stats is all going to be about how we collect data, how we can organize it, and present it. And you know what? I'm going to add one more. And analysis. So we collect data, organize it, we can analyze it, right? You might have heard of words like mean, median, mode, right? That's like a very simple form of analysis. And then we have to present our data. So Dot, what better than let's do a class poll. So yesterday on Google Forms, I asked you how many siblings and first cousins combined do you have? So I collected this data on Google Forms. So I'm going to tell you how many siblings and first cousins I have. I have 2 older brothers, and I have, let me count, 1, 2 on that side, right, just 2, 3, 4. All right, so for me, I have 6 siblings and first cousins. So how many do you have? I'm going to share my Google Forms slide with you. So here we go. Let me share this. And I'm hoping you can see this page now. All right, so I'm just going to write down each of the results. I got 19 responses. All right, so in the next box, this person said they had 5 siblings. So let's write that down, 5. All right, next person, 3. So this data is completely unorganized. In the next box, write down a 4, right? Because this just comes into order that I've received it from you. All right, so next person, they got 10, then 7, 4. Right, I usually go around the classroom and get this info. But over here, this works fine. We got 9, here 6, 3, 7, 5. This person has 1. 3 siblings, 8 first cousins. That adds up to 11. Next person has 10. This person has 4, 7, 4, 0 siblings, and 8 first cousins, and 11. All right. So hopefully if you were filling that out with me, you have the same looking table here. So there is all our data. So we did the first step in what we're calling statistics. We collected data, right? So how can we better represent or organize this data so we can present it properly? Well, there's lots of different ways, right? We could put the numbers, first of all, in least to greatest order, right? Or we can make some kind of bar graph or a histogram you might have heard of. But the first way we're going to organize our data is a very basic way. We're going to do something called a dot plot. All right, so dot plot, it's just a pretty basic visual way of organizing our data so we can see it better, right? Because a lot of statistics is about visualizing or seeing your data and noticing patterns or trends. So down here, I'm just going to make a straight line, right, like a number line, and this is going to represent number of siblings plus first cousins. So I notice my data goes from 1 to 11. So I'm going to start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm just going to put a dot each time I record one piece of information. So just go to a big networks. All right. So 6, one person had 6 siblings. So I recorded that piece of information down. I'm going to cross it out. All right, 5 for the next one, 3 and 4. All right, so all the first dots should, of course, be on the same level. Next person had 10. 7, 4, 9, 6. 7, 4, 9, 6. So you just stack up the dots. Now we have 2 dots on top of 6, 2 dots on top of 4. All right, 3, 7, 5. 3, 7, 5. 1, 11. 1 and 11. 10 and 4. 10, 4. 7, 4. 7, 4. 8 and 11. 8, 11. All right, so there's our data. And we can see that it seems most people are clustered around this area, but there do tend to be some people with a lot of siblings and first cousins. This actually is not even that much. Oh, no, come on. It's not even that much because I've seen some people with like 20 or 25 siblings and first cousins combined. But then we do have a lower end. This person only has 1 sibling and first cousins. So, right, so it's a nice visual way of seeing our data. We can see patterns or trends, or we can see things called outliers. I'm not really sure if this is an outlier or not, but an outlier is like a piece of data that is very extreme. And we'll go into an exact definition later. But for example, if someone had like 23, let's just make that up, right? That would definitely be an outlier based on our sample or our data set here. All right, so the reason we gather stats is because we want to compare, right, to kind of like the average, right? In basketball, you know, someone that scores 35 points per game is scoring a lot of points per game because that's a lot higher than the average, right? That's a lot higher than what the normal NBA player scores. So how do we measure what is normal? So what do you think would be a good way to measure the normal amount of siblings and cousins the class has? So the 3 main ways of measuring what's normal are called the three measures of central tendency, right? The three measures of central tendency. And they all have some advantages and times when we want to use them. And you might have heard of these before, right? So I think most people would probably say take the average, right? So that is what we call the mean, right? The mean or the average. So the mean might be a good way to measure the normal, or what's normal for this class. So how do we measure mean? Well, how do we get the average? We're going to add up, right? Add up all the, well, actually, let me just write a formula for this. So the mean or the average, right, that's equal to the sum of all individual data values. So imagine if you're getting the average of 5 test grades, you're going to add up all your test grades, that's the sum of all of your data values, right? And you're going to divide by the number of data values, right? So if you add up 5 test grades, you're going to have your 5 test grades and divide by 5, that's the average. So the average for here is we're going to add up all the individual data values. So we're going to do 1 plus 3 plus 3, right? I'm just counting or looking at those, right? And make sure, because we have 3 dots on 4, we got to add up 4 3 times. So 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5, right? If you want to just write that as 10, you can. You want to simplify a little as you go, all right? So I'm going to start simplifying instead of writing every single bit of data out. So on 6, I have 2 6s. I'm just going to write plus 12. On 7, I have 3 7s. I'm going to write plus 21. Plus 8 plus 9. Plus 2 10s, that's 20. Plus 2 11s, that's 22. All right, so our average here is going to be all of that. And I shouldn't use the word average. Let's use the word mean. Our mean is going to be all those numbers divided by, well, how many data values do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 20 data values, all divided by 20. Right, and let's calculate this real quick. I'm sure you can type this into your calculator. Make sure you're doing control divide to get that fraction to avoid mistakes. But 1 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 12 plus 21 plus 8 plus 9 plus 20 plus 22. All right, I'm getting 121 for our top. All right, divided by 20. And our mean here is 6.05. So around 6, right? You do not want to round that to 6 because 6.05 is what we got. Right? And I know you can't have 6.05 siblings and cousins, right? But the mean doesn't have to be like an actual data value we got in data collection, right? It just represents, well, around, our average is 6.05. Right, just like if you got 100 and a 90 on the test, your average is 95, doesn't mean you got a 95 ever. So that's the mean. The next is going to be the median. The median is another good way to measure what is normal in the data set. Right? So the median definition, that is something that's also called the 50th percentile, right? And that is the middle data value when data is arranged from least to greatest. So it's called the 50th percentile because half of your data is going to lie below the median and half of your data is going to lie above the median. So the way of getting the median here is let's write down all our data. I'll show you two ways to do it. Let's write down all our data from least to greatest. So we have 1. Then we have 2 3's, so you need to write down the 3 2 times. So we're going to write down 1, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 7, 7, 8, 9. We had 2 people with 10 and 2 people with 11. So there we go. We wrote down our data from least to greatest, and now we're looking for the middle data value. So literally what we do is we cross out data, one from each end, until we get to the middle or the center of our data set. So I'm going to cross out 3 and 11, 3 and 10, 4 and 10, 4 and 9, 4 and 8, 5 and 7, 7 and 7, and 6 and 7. All right. Did I do this correctly? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I knew I messed up because I shouldn't have a single number in the middle because I knew I had 20 data points. This must mean I missed writing one of my numbers. What did I miss? I have 2 11s, 2 10s, 1 9, 1 8, 3 7s, 2 6s. Ah, I missed a 4. I have 4 4s. I only wrote down 4 3 times. I gotta add another 4 here. And I also gotta add another 4 when I took the mean. So hopefully you're yelling at me over the computer, telling me I missed that 4 earlier. So let me recalculate the mean. It's actually going to be 6.25. And the median, the new median is, hold up again, I'm going to take a little shortcut this time. I'm going to cross out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just get closer to the center first, and now I'll cross off 1 from each end. And you'll notice we have 2 numbers left in the middle. When that happens, you take the average of those 2 middle numbers. So I know they're both 6s, so the average of 6 and 6 is, of course, 6. But if you have 2 numbers in the middle, you want to take the average to find the median. So take average, or the mean, if 2 values in the middle. All right. So average of 6 and 6 is 6 plus 6 divided by 2, which is 12 over 2, which of course is 6. So our median is going to equal 6. All right, so according to the median, what's typical or what's normal is for people to have around 6. That's pretty close to our mean. All right, but these are just 2 different ways of measuring. Right, it's called central tendency, what the data tends to centralize around. Right, and the last measure of central tendency is called mode. So we got mean, median, and mode, and they all start with M. All right, so the mode, this is the data value that appears the most often. All right, this is the data value that appears most often. So if we take a look at our data, I believe the mode is 4 because that showed up 4 times, which is more than any other number. So if it if you have two numbers that showed up 4 and that was the most, then you just write down 4 and 7. Right? You can have more than one mode. That's fine. So let's take a look at this data over here. How many people ran the 100-meter sprint? All right, we just count the number of dots. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, find the 3 measures of central tendency for the data shown above. Round to the nearest 1/10 of a second. All right, so if you want to practice getting mean, median, mode, let's try that now. The mean is going to equal, well, so the mean, if you wanted to figure that out, again, just add up all these numbers. So 10.1 plus 10.2 plus 10.2 plus 10.2 plus 10.3. All right, so try calculating those 3 measures of central tendency. All right, what I'm getting when I added them all up, all right, if you want to pause the video to avoid spoilers, I got 208.9, right, divided by 20, and that is equal to 10.445. So it says round to the nearest 1/10 of a second. So that means the mean time is approximately 10.4 seconds. So the average time it took someone to run a 100-meter sprint is 10.4 seconds. All right, the median. So, oh yeah, I forgot to show you the other way of getting the median for this dot plot. But instead of just writing out all the data, which you can do that. You can write 10.1, 10.2, 10.2, 10.2, etc. Right? You can also cross out on the dot plot. If they give it to you as a dot plot, you can just cross out on the actual visual data. So we can cross off 1 from each end. So I crossed off a 10.1 and a 10.9, 1 from each end. Right? A 10.2 and a 10.9, a 10.2 and a 10.7. So I recommend just being consistent the way you cross out. So I've been crossing out coming from the top to going to the bottom. So I'm just always going to start crossing out from the top first. And make sure you do 1 pair at a time. So I'm doing 1 pair at a time. 1 pair at a time. 1 pair. And then cross out 2, right? 1 from each end. And so we're left with 2 numbers in the middle. They're both 10.4 again. And so again, our median will be the average of 10.4 and 10.4, which means our median is 10.4. Right, so we could have done that in the previous one as well, instead of writing them out from least to greatest. And so what is the mode? We got 2 modes here, right? Looks like both 10.3 and 10.4 appear 4 times each. All right, so that's just the calculations of how you do mean, median, mode, right? Nothing too crazy. And so which measure do you think best represents the normal 100-meter sprint time? So I don't think there's any times too crazy. So, right, this seems all pretty normal-ish. So, and our mean and median, they were both pretty much the same. So, yeah, I would say the median or mean, those are both pretty good to represent what's normal, right? And in this case, even the mode represents pretty much the same thing. So I'm just going to go with median or mean here. But this is an interesting case. What's going to happen if there was someone that fell down when doing the 100-meter sprint and had a time of 23.4 seconds? Add that data onto the dot plot above. Right, so imagine a little break here, and there was someone that had a recorded time of 23.4 seconds. Well, how is that going to change the mean? And how is that going to change the median? So let's take a look at what the new mean would be. Our new mean is going to be equal to Well, our old mean was 208 plus 208.9 over 20. So the sum of all of this data, that's still going to be 208.9, right? We're just adding one extra data point. So I can keep the 208.9 and add 23.4. But what would we be dividing by now to get the mean? Well, now we have 21 data values. So our mean is going to be equal to that. So let me do that calculation real quick. That is 208.9 plus 23.4 divided by 21. And look what that does to our mean. It boosts it up to 11.06, right? So if we're rounding to nearest tenth, our mean is now approximately 11.1 seconds. And what is our median going to be? Well, if we still cross out one from each end, if you want to repeat the process, we're going to be left with a single dot. I believe this single dot in the middle. But our median is not going to change. Our median is still going to be 10.4. So if I ask you now, which better represents the normal 100-meter sprint time? Well, I would go with the median, right? Most of my data is clustered around the center value here, right? And this median of 10.4, that's a lot more representative of what's normal than 11 is, right? Only one person ran 11. All of our data is over here. So this 23.4, that really skews our data, right? Or pulls up the average. So the median is going to be much better. Will be much better representation whenever there are extreme. So what we call that 23.4, we call that an outlier, right? So an outlier, that's a piece of information that is very distinct, very different, either much higher or much lower than the rest of your data. And you can have more than one outlier. Right, that outlier could have also been someone that ran it in like 6 seconds, which is impossible, by the way. But the median will be a much better representation whenever there are extreme outliers, right? Because those outliers, you're going to skew our data or make it not really representative of what's really average, right? It's either going to pull up the average by a lot or bring down the average by a lot, right? It's kind of like if we're trying to find the average salary of a Great Neck teacher, but Bill Gates suddenly decided to become a teacher at Great Neck, right? And now if we take, I guess not salaries, I guess average amount of money in the bank account or something, but once we take into account Bill Gates' average, right, the average teacher is going to be a millionaire. So obviously that is not quite representative of the true case here. All right, so I also told you about what is your favorite color. So I am not going to share my screen again because that takes a little bit of time. All right, I'm just going to record the data myself and go back to the first individual and start recording data. All right, so we got 1 vote for yellow. Next response, person chose red. All right, and then blue. You know what? I'm actually gonna pause the video and just fill in the data. You can copy it. So, all right, so I just tallied up all the data and we got 6 for red, 1 for orange, 1 for yellow, none for green, 9 for blue, 1 for purple, and 2 for pink. So, poor green. No one likes green. So which measure of central tendency can we use to represent the class's favorite color? So while usually we use mean or the median to represent what's normal, right? Get the typical amount. Well, can we take the average of different colors or find the middle color, right? So it doesn't really make sense to take the mean or median here. So the only one that really makes sense is to use the mode. And our mode here is equal to blue, right? It's not equal to 9, it's blue, right? The mode is what appears most frequently, and blue appears most frequently with 9 times. So it makes sense to use the mode when our data is not numerical like this, right? When our data is something like what's your favorite color or what's your favorite ice cream flavor, right? Then we have to use the mode because it doesn't make sense to do mean or the median. So answer there is no. So to summarize, we got these 3 measures of central tendency: mean, median, mode. I'm just going to copy and paste the definitions from here. But these are what you need to know for today. So very simple lesson today, right? We got the mean, also known as the average, right? Which is what you get when you get the average. So you sum up all of your individual data values and divide by the number of data values, right? We got this thing called the median, which is also called the 50th percentile, right? Because that's the middle number. So 50th percentile means that 50% of your data is less than the median and 50% of your data is more than the median. If you need a hint to remember the word median, right, it's the one that sounds most like middle. So median, that's your middle. Mode sounds like the word most. So that's also pretty simple. They're all also both 1 syllable and 4 letters each. So a trick to remember the mode is the word most. That's the one that shows up the most. And mean is average, right? That's the hardest one to do calculation-wise, even though it's not bad. So there's that. All right, so that's going to be it for today. Pretty quick lesson. And I'll see you guys on Friday. So take care, stay safe. See you guys later.